A stable atmosphere exists when the decrease in air temperature with height is less than the moist adiabatic rate. When this atmospheric condition occurs, the unsaturated air inside a lifted parcel will be colder, heavier, and more dense than the air surrounding it. So when the parcel is released, it will fall back to its original position. An unstable atmosphere exists when the decrease in air temperature with height is greater than the dry adiabatic rate. When this atmospheric condition occurs, the air inside the lifted parcel will be warmer, lighter, and less dense than the air surrounding it. So when the parcel is released, it will continue to rise away from its original position. A conditionally unstable atmosphere exists when the decrease in air temperature with height falls between the moist and the dry adiabatic rate. A conditionally unstable atmosphere may become unstable if a rising air parcel becomes saturated and a cloud forms. The latent heat released inside the cloud warms the air to the point that the rising air is now warmer and less dense than the air surrounding it. The cloud will continue to build until the rising air inside the cloud becomes the same temperature as the air surrounding the cloud. As air rises up along a mountain, it may cool to its dew point, forming a cloud. The release of latent heat inside the cloud warms the rising air. This situation causes the air inside the cloud at the top of the mountain to be warmer than it would be otherwise. Condensation and perhaps precipitation on the mountain's upwind side removes moisture from the rising air, so that the rising air at the top of the mountain is also drier. If the rising air at the top of the mountain should descend the mountain's leeward side, it would produce a warm, dry, downslope wind that may replace cold air embedded in low-lying regions. This sinking, warming air may also inhibit the formation of clouds and precipitation, producing a rain shadow effect.